To isomorphism, how many additive abelian groups G of order 16 have the property that x plus x plus x plus x is equal to 0 for each x in G? Okay, so I think the way to do this is to use the classification of finite abelian groups, which G basically has to be, if G is a finite abelian group, then G has to be a product of, and it's of order 16, right? Then G itself has to be a product of cyclic groups that are powers of 2. Now, so what are possibilities? So we could have Z2 times itself 4 times, right? So each of these individually has an order which is equal to 2, so the whole thing is order 16, and this will satisfy the property that x plus x plus x plus x is equal to 0 for all x. Other possibilities of G are something like Z mod 4 cross Z mod 2 cross Z mod 2. Again, this satisfies this property because this is satisfied within each of these individual groups. Same thing here, it's satisfied in each of these individually, and so it'll be satisfied in the product. And the other one that'll work is Z mod 4 product Z mod 4. Now we can't go any higher, so if I had, for example, G is equal to Z mod 8 product Z mod 2, this doesn't satisfy the property that x added to itself 4 times is 0, because I could take the identity in here and just take an element in here such that, just take the number 1 in here, add it to itself 4 times. You don't get 0, you get 4. So the answer to this, I'm sure, is going to be 3. I'm sure these are the only 3 options. Again, it's up to isomorphism, so the order that I draw, that I write them in, doesn't matter. And you have to use groups that are, when you break it up, when you break up the full group into these products, the ones that go here must be of order at most 4. So it's either 2 or 4, and the only ways to do it are like this, or like this. Yeah, so my answer is going to be 3, which corresponds to multiple choice option D. It's just, this question basically just came down to knowing that, if you have a finite abelian group, it's essentially just a Cartesian product of cyclic groups where each individual component of the product is a factor of 16. Now it's nice that they gave us the number 16, which is just got powers of 2 as factors, so we don't have to fiddle with, if this were some 24 or something like that, it'd be a little bit more fiddly with how to do all this. Anyway, that's my answer. I haven't studied algebra in a really long time, so if I'm applying some of these ideas incorrectly, then I might have a mistake. But if that's the case, I'll let you know. Thanks for watching.